Hey guys, this is Mr. Kim here. Welcome to another day of chemistry. So, I thought to make a quick video on the recent worksheet that we worked on, right? This is on using mole bridges, also known as molar ratios, of balanced equations to predict how much products that we could form with a given amount, right? So let's go ahead and start with some of these questions that we've not done during class. So here's number 2 that I'm going to do with you guys, okay? So follow up with me. Now, you always begin with step 1, balancing your equations, okay? Now, this one I'm not going to because we've already done it during class, right? So we have here so far 2, 1, 1, 2 as my coefficients, right? These are my molar ratios that I'm going to be using. All right, so let's go ahead and read this question now. How many moles of H2S are needed to produce 1437 moles of HCl? Okay, I'm going to go ahead and highlight a couple of things here, okay? Now, I am given this much amount, right? And I want to see how many moles of this do I need with the given amount, right? So what I'm trying to do is to set up a bridge between moles of HCl and moles of H2S. Okay, so as always, I like to set up, okay, what is my objective for this question here, right? So I'm going to go ahead and write that down. So that's 1437 moles of HCl is equal to how many moles of H2S would that be? All right, so that's my goal here, right? So I'm going to leave that on the left side, and I'm going to think, okay, to go from HCl to H2S, I need some sort of bridge that would take me there, right? Also known as the molar ratio, right? So what is the ratio between HCl and H2S? Now, if you're thinking, where do I find that information? You need to go back to your balanced equation, all right? So let's go ahead and see. Looking at my balanced equation above, okay, I have 2 HCl, right? And what is the coefficient in front of H2S? There isn't one, right? But we do know that if there's not a coefficient, it does not mean that it's a 0, however, but it's a 1, right? So I'm going to go ahead and write that 1 in here. And that's it. So that is my information. That's my mole bridge that I set up. Now, what I'm going to do with this is that I'm going to clean up a little bit. Shrink that in size. Leave it on the left side, okay? Because I'm going to need it very soon, all right? So let's go ahead and do my calculation here. So I'm going from the given amount, right? So it looks like it's just going to be a one-step process. Great. 1437 moles of HCl. Nothing going down here, right? Now, because I'm converting from moles of HCl to moles of H2S, I'm going to be needing the same unit down here, right? Which would be HCl. And if you look back to your mole bridge that we just found, it looks like 2 moles of HCl and 1 mole of H2S. And that's it, right? Moles of HCl and moles of HCl, they cancel away, the units. And the only thing that's remaining here is the moles of H2S, which is what we're trying to find here. Okay? So let's go ahead and try that. All right? So that's 1437 divided by 2. And that's going to be 718.5 moles of H2S. That is my final answer. I'm going to go back to my objective that I wrote down here. I'm just going to squeeze that in. Why not? Okay? So that's number 2. Let's go down and try these 2 questions. Okay? 5 and 6. As always, make sure you have everything balanced. Okay? Let's see. Now, this one's a little bit tricky, balancing equations. All right? So you're going to have to grab like a piece of paper to see which one would work. And if you do finish, you should get something like this. 1, 3, 2, 3 ratio. Okay? Yeah, I know this one was a little bit tricky, right? I hope you got that part. Once you have that information, why don't we get started with 5 and 6, okay? 5, we have 13 grams of Fe2O3 will require how many grams of CO to react completely? Okay, so again, I'm going to go ahead and highlight a couple of things here. I have 13 grams of Fe2O3 and how many grams of CO? Okay, so I'm trying to go from grams to grams here, right? So that's going to require a little more information than the previous question, all right? So let's go ahead and set up the objective for this question. I'm going to go ahead and write down 13 grams of Fe2O3, okay, is equal to how many grams of carbon monoxide? That is my goal here, right? Great. So once I have that set up, I'm going to have to think ahead a little bit. Okay, what else do I need? Okay, first of all, I definitely need a mole bridge here, right? I need a mole bridge that will take me from Fe2O3 to CO. So let's go ahead and write that down. All right. O3 is equal to how many carbon monoxide? All right, so where can I find this mole bridge information? Again, back to our balanced equation, right? So in front of Fe2O3, are there any coefficients? No, there is not. So I know that this is just 1 of Fe2O3. What about CO? Yes, there is 3 in front, okay? All right, so that's good. So that part is set up. Now, what else do I need? Okay, I want you to keep in mind, guys, using these mole bridges, right? It's called mole bridge for a reason. The reason why it's called mole bridge is because you have to have everything, all the amount in moles to use the mole bridge, right? So here's what I mean by that. Go back to how much of Fe2O3 that is given in our problem here. 13 grams of Fe2O3. Does that mean moles of Fe2O3? No, it's not. So in order for us to use the mole bridge, you have to make sure that everything is converted to moles before making that, using that mole bridge, okay? So let's go ahead and try. How do I convert from grams to moles? How do I do that? By using the molar mass, okay? You can find the molar mass on your periodic table, right? It's that number underneath the symbol of that given element, right? So your job right now is to add up all the elements together to find the molar mass of the compound. Let's go and do it. All right, here we go. I'm going to need 2 molar masses here, right? I need the molar mass of Fe2O3 as well as CO. All right, so let's go and do some math here. Fe2O3. What is the molar mass of that? Right? So Fe, iron, is about 55.8, right? 55.8. And I have to make sure to multiply that by 2. Why is that? Because I have this subscript, right? So go ahead and multiply these 2 parentheses. And one more, oxygen is going to be 16, and there are 3 oxygens, right? So that's 48. All right, so let's go ahead and do some math here. To my calculator, 55.8 times 2 plus, that is 48. All right, so I got 159.6, but you know what? I'm just gonna round it up a little bit, make things easier, okay? 160 grams, okay? I got 160 grams per mole. Now that is the molar mass of Fe2O3. All right, what about carbon monoxide here? Okay, this one's pretty straightforward, right? Each carbon is 12 and each oxygen is 16. That is 28 grams per mole. All right. Okay, so I have all the information that I need to get started with this question. That took a while, right? All right, so here's what I'm going to do. I'm going to shrink this one a little bit. Okay, I hope that's still visible for you guys. Shrink this size as well. And I'm going to move it to the left a little bit, okay? I'm sorry, it's really small, right? Because I am going to be needing a lot of space here. Okay, let's draw a line here so that I know to the left of that line, vertical line, all the information that I need to get this question started. All right. I hope that's long enough. Okay. Start with my first fraction. As we know, nothing's going down here. And always you begin with the given amount, guys. Okay, I've seen a lot of students make mistake of starting with like a random substance. No, no, no. You always need to begin with the given amount. All right? And that is 13 grams of Fe2O3. All right, here we go. All right, so before using the mole bridge, what do we have to do? We have to convert it to moles in order to use the mole bridge, right? It's not the grams bridge, but it's the mole bridge. So how do I convert? Again, use the information that we just found, which is right here, right? So that is 160 grams of Fe2O3 for every 1 mole of Fe2O3. Done. That part is now done. Now I have everything in terms of moles of Fe2O3 because these two units go away, right? Okay, now I can finally use the mole bridge, right? So that I can convert from Fe2O3 to CO. We're going to do that right here in the next set. And the mole bridge tells me that, okay, for every 1 mole of Fe2O3, that gives me 3 moles of carbon monoxide. Oh, actually, I'm going to use a different color so that you can see where I got these red numbers from, right? To the left side. Okay, so what else can be crossed off here? Moles of Fe2O3 and that one as well, okay? Now everything is in terms of moles of carbon monoxide. Is that what I'm trying to get here? No. Look back to your original question. It says, what is the grams of carbon monoxide? Okay? So what I'm going to have to do here is to convert from moles to grams. All right, how do I do that? Use the molar mass, right? And that could be found, I'm going to highlight it again, down here as we did, right? So let's go and try that. So I got moles of carbon monoxide up top, which means naturally I'm going to be needing, different font, mole of CO, that is, we said 1 mole of carbon monoxide is 28 grams of carbon monoxide. Okay? So those units are gone too. Therefore, the only unit that is left is grams of carbon monoxide. Is that what we want? Yes. Back to your original question, how many grams of carbon monoxide, right? There, we have that. All right, so let's go ahead and finally do the calculation, okay? So here's what I'm going to ask you to do. Multiply everything across, okay? Multiply the numerators together and multiply the denominators together and divide those two numbers at the very end, okay? So here's what I'm doing to my calculator. Ready? 13 times, don't times it by 1, okay? 13 times 3 times 28. So I got 1,092, and I'm going to divide that by 160. That's it. Okay. I'm going to report it to, let's see, 3 numbers. So 6.83 grams of carbon monoxide is what I got for this question. Okay. I'm going to just fill it in here because why not? 6.83 grams of carbon monoxide. I hope you guys got that question as well. Okay. All right, let's try one more question here. Number 6. Okay, now this one I'm going to really try to speed through. It'll be very similar to what we just did for number 5, okay? All right, here we go. 13 moles of carbon monoxide will produce how many grams of carbon dioxide? Oh, okay. All right, there's a difference between monoxide and dioxide, right? Mono means 1, di means 2. All right, so here's my objective. 13 moles of carbon monoxide equals how many grams of CO2? All right, let's see. First, I'm going to set up my bridge. And that is back to your balanced equation. I got 3 to 3. Ah, okay. All right, so it's basically 1-to-1 ratio, right? All right, so what else do I need? I need to set up my molar masses because anything that involves grams, right? You have to make sure that you know what the molar mass of that is, right? So for 13 moles of carbon monoxide, you don't need the molar mass here, obviously, right? Because that's already in moles. However, for the other part, the back part here, it says how many grams of carbon dioxide. So carbon dioxide is CO2. Each carbon is 12 plus, open up the parentheses here, 16 for every oxygen times 2. So that is 32. That is 44 grams per mole. Okay? Sweet. That is all the information that I need for this question. All right? I'm going to go ahead and just set that aside. All right, let's begin. Let us begin. Here's a line. Oh, that was a good line. Okay. Begin with the given amount, 13 moles of carbon monoxide, that's CO. So, okay, now, since I have my given amount in moles already, guys, okay, I've seen you guys do this in class a couple days ago. Don't convert it back to grams. Why? There's no need to, right? Because it's already in moles, you do not need to apply the molar mass here. So you're going to actually use the mole bridge directly, right away, okay? So back to your mole bridge. So 3 moles of carbon monoxide. That gets me also 3 moles of carbon dioxide. Boom. Moles of CO, moles of CO. The units are gone. All right, so everything is in terms of moles of CO2 now. But my question is asking me, how many grams of carbon dioxide? How many grams of CO2, right? So now I'm going to have to use my, what? Molar mass that we just found here, CO2. Okay? All right, so that is, for every 1 mole of CO2, that is 44 grams of CO2. And that's it. Okay, that one was a lot shorter, right? Let's see. Now I'm going to make sure I cross away all the units that I don't need. Boom, I'm left with grams of CO2, which is exactly what we want. All right, so here's what I'm going to do. If you know simple the rules for reduction of fractions, the same number or same variable up and bottom, right, top and bottom, will reduce themselves, right? So these 3's can actually go, just they dissolve, they reduce to 1, okay? So all I have to do here really is just 13 times 44, and that's it. 13 times 44. I got 572 grams of CO2 as my final answer. Sweet. That was pretty easy. 572. Okay, that was shorter, right? All right, let's go to back part now. Let's do some STP questions, standard temperature and pressure. Really just means molar volume, right? We know what that is, right, guys? That's 22.4 liters is equal to 1 mole, all right? For every mole, it takes up 22.4 liters of space, okay? All right, let's go ahead and try this question out. So I believe this question, I think this was a 2 in front. By doing so, I have 6 carbons, so I'm going to put a 6 in front of this one. Okay, and I have, what is that, 16 hydrogens. So if that's 16, I'm assuming this is 8. All right, so let's take a look at the total number of oxygens I got here. 6 times 2, so I got 12 oxygens, and I have 8 oxygens. That's 20. So, boom. There you go. Right? Okay. Oh, maybe not. Maybe okay, here's a quick tip, guys, okay? Take a look at all the coefficients here, right? 2, 10, 6, 8. What do you notice? They all can be divided by 2, right? Then you know, uh-oh, something's wrong. If they are divisible by a same number, so if I were to reduce this, what would I get here? I'd get 1, 5, 3, and 4, right guys? Right? So I'm gonna go ahead and get rid of the ones that I had initially. Okay? And let's see if this works. It should. Okay? So let's see. I got 3 carbons on the left side, and I have 3 carbons on the right side here as well because of this coefficient, right? So that one's good. What about my number of hydrogens? I got 8 on the left side, right? I got 8 here. And do I have 8 on the right side? Yes, I do. Here's a 2 multiplied by 4. That's 8. Okay, now what about my number of oxygens? I got 5 times 2 here. That gives me 10. And let's see. So that's 10 oxygen. I'm going to write it here. 3 times 2, I have 6. And I have 4 times 1, 4. There you go. 6 plus 4 is 10. Okay? Oh, I don't know. For some reason, I've just sort of assumed that this one you would need 2 in front of that big compound here. But I guess not. Okay, so that sort of worked out. 1, 5, 3, 4. Gonna get rid of that 1. Okay. All right, so here's my balancing equation. With this, I'm going to go ahead and see, okay, if 8.75 liters of C3H8 react, calculate the following ... Here's part A. The volume of oxygen that reacts. Okay, so here we go. Let's go ahead and write out some of the information that I need for this question. 8.75 liters is equal to how many liters of O2? That's what I'm trying to find here, right? When you see the word volume of something, always remember that that's liters of that something, okay? So that's my objective for this question here. All right, let's see. What do I need? Well, I know that I need the bridge between C3H8 and O2. So let's go ahead and set that up too. How many C3H8 do I need for the oxygen? And that can be simply found by using the balance equation that we just had up there, right? What is that? That's 1. And for oxygen, that is 1. 5. Okay? All right, so that is all I need for this one, okay? These volume questions are really a lot easier, I'm going to say, because you don't have to use the molar masses. There's less work, okay? And of course, we're going to be needing the volume, the molar volume equation, right? 22.4 liters is equal to 1 mole. All right, so let's go ahead and set up this question. Here we go. Start with the given amount, 8.75 liters of, what is that? C3H8. Sorry, guys. I'm like running out of space here. Okay, hope that's okay. All right, so that's 22.4 liters of C3H8 for every 1 mole of C3H8. Okay, gonna need more space. All right, now all the units, these two go away. I'm left with moles of C3H8, okay? Now, since everything is in terms of moles, I can finally use the mole bridge here, okay? And the mole bridge was what? 1 to 5 ratio, guys, right? 1 mole of C3H8, 5 moles of C3H8. All right, almost there, almost there. Now, every time you use a different unit, you're going to have to cross away, as I did just now, right? So I have 5 moles of C3H8. Oh, sorry, this is... Oops. I meant to say O2 here, guys. Terribly sorry. Okay, 5 moles of O2. We good? All right. So now I want to make sure that I have everything in terms of liters. So here's what I'm going to have to do. So convert from moles to liters. You're going to have to use a molar volume equation again, right? So that's simply 1 mole of O2, 22.4 liters of O2. That's it. All right, so we're going to go ahead and do the calculation across, okay? Top and bottom, right? So 8.75 times 5 times 22.4 and divided by 22.4. And I got 43.8 liters of O2 as my final answer. Okay, guys? All right, let me go ahead and clean that up a little bit. And I'm going to show you guys something here. If you look very, very carefully, what do you notice? You notice that, okay, well, this and this can actually be crossed away like that, right? So the only thing that you're really going to have to do is just take your original volume, and if you just multiply by the mole bridge, actually that's it, right? So there's that extra step here. That's the steps that you would need to take. But calculation-wise, all you really just have to do here is take the original volume and multiply by the mole bridge, and you should get your final volume. Okay, so with that idea, I'm gonna actually apply that to this one, to the next one. I'm gonna show you what I mean by that, okay? So my original given amount here, right? So that's 8.75 liters, okay? And I'm gonna take that, and what's the mole bridge between C3H8 and CO2? I'm gonna highlight it, okay? It's right here, and CO2 right here. So that's really just 1:3 ratio, right? So 1:3 ratio, okay? C3H8 and CO2. That's actually all you have to do, and that's it, okay? So I'm going to take 8.75 times 3. You can go the long way, you can go the short way. 26.3 liters of CO2. Okay? So I'm going to do one last time using that short method, okay? If you want to do the long way, the short way, they're both fine, but just know that if you're just going from liters to liters using the molar volume and using the mole bridge, all you actually have to do is multiply by the mole bridge, the molar ratio, okay? All right, let's go ahead and clean that up a little bit and try the last question here together, okay? So given amount is 8.75. Okay, 8.75 liters of C3H8. Let's go ahead and highlight that. So I'm going from here to H2O, water. Okay, so what's the ratio between them? It's 1:4 ratio, right? So to set this up, 8.75 liters, and that is that's water, right? Not water. That is what is that? C3H8 and 4 water. Okay? So to multiply that, 8.75 times 4. 35. Exact. Okay, 35 liters of water. And that's it. Okay, so if you take parts B and C, work it out the long way, you should get the same answers. Okay? All right, I'm going to stop here today. I hope this was helpful. All right, I'll see you when I see you.